Greetings to all of you. I am Kavita from Steps Knowledge Services. We are into explaining online industrial imaging system based on ARM Cortex-M4X series. So the objective of the project is a LandScan industrial imaging system with CCDs or photodiode arrays. The intent was to use TI Cortex-M4X as the heart of the industrial imaging system, which offers good reduction in the system part count and the system power requirements. Such designs have an FPGA or a DSP for the image processing section, which is this section, and generally they do have an FPGA or CPLD for the timing generation. They also generally require an analog front-end system to properly interface the CCD analog signal to the image processing blocks. So the applications of this project are all machine-vision based applications. There are a lot of applications in fact. So it's including high-speed online particle impurities detection, shape and edge detection, defect identification, barcode scanning, image scanners, etc. So a lot of applications are available like position detection, image reading, encoder, barcode reader. The design can be used in any industrial imaging system which can scan online and identify a defect at an abnormally high rate up to 20 MHz. The innovation here is to use the ARM Cortex-M4X as the single system on a chip for all the functional blocks. This would enable to replace a DSP, FPGA or a CPLD which generally form part in the image processing and timing generation. All this combo into a single ARM microcontroller Cortex-M4X. A small DOM, good processing power, affordable cost, reduced form factor and lower power consumption and a very good external interface mechanism make the ARM Cortex-M4X an ideal choice. The market potential in this case is that there is still a lot of needy applications which require a low-cost online imaging system, which generally the current commercially off-the-shelf system are still costlier for deployment into these products. Some of these applications do not require an image reconstruction or a compression or streaming algorithms, which are generally required on any consumer application or a consumer imaging system. Most of the online applications are high-speed systems for a flow of material which have to be subjected to an imaging unit, and the defects, abnormalities, non-linearities or a product mix need to be identified, and some defect elimination mechanism is in place, for example a pneumatic suction. The technical features of this product is that it can be interfaced to any photodiode, CMOS or linear image sensor like the examples of these sensors that we have looked into are Panavision LS 1024 and Deluxe 2K series, monochrome sensors, Sony ILX522K, CCD linear sensor and ILX524K, Hamamatsu 2048 pixel monochrome sensor with an integrated amplification available within the sensor, Kodak KLI series, both monochrome and color CCD sensor. For the photodiode arrays, Cortex-M4X is more than sufficient to take part into all the blocks, including the analog front-end, image processing and the timing generation. For CCD systems alone, we are toying around the idea to find an equivalent of how with minimal system part count we will be able to emulate an analog front-end which is available on the market. The other features are high-speed image scanning and abnormality identification with its corresponding action. It could trigger a lot of actuators, valves, independent scan control and diagnostic network, multiple serial port interface, UART, SPI and I2C, USB on-the-go interface for data logging and connectivity as a device, data stream output, micro DMA. But what happened was we were not able to identify all the CCD and CMOS parts. They are still being shipped. They have been ordered and still being shipped because some of these parts were not available in element14.com. So we are yet to interface. We have already done some simulations using CCS for all these applications. for all these interface of all these photodiodes, but still we have not zeroed down on a working prototype. But we have looked at the total Stellaris libraries that are given, which are very, very excellent. They have a pre-compiled set of libraries, so a good head start could be done very quickly. So with this, we conclude on our current product, which uses the online industrial imaging system with an ARM Cortex M4F. Thank you.